Hello friends, so in this particular video I will be talking about the variable and the definition. So how exactly the variables play a role in the PLC programming world. So there are a lot of different variable types, and I will walk you through different parts of variable in this video. So let me go through it one by one. So in the CoDeSys, we can define different kind of variables. So let me first walk you through the help file where you can find the different variables supported by the CoDeSys. So these are the variables like var input, var output, var in out, var global. Okay, so these are the supported variables type. Now let's first go to the var global. So I'm adding it the var global. So we have to go to add object and global variable list. It will give us a pop-up where we need to give a name. So I have kept it as a GVL, global variable list, short form. So when we add that, what we get is var underscore global and end var. So anything which is any variable which is defined in this particular region will be marked as a global variable. Which what does it mean? It means that we can access this particular variables at a different program also. So these are globally scoped from anywhere you can access in the program, and it supports both read and write. So it is not about only you can read it, but also you can change the values from a different program. Okay, so I'm defining two variables. GV I have given as a prefix like global variable just to mark highlighted. Now let's go to PLC program. Okay, I'll add another program and it will be also marked in structure test. So let me define this. Let me put the different name. So PRG. Okay. So as I told, this GVL, anything divided on the global var global can be accessed anywhere. So if you see what I'm trying to do is I'm writing a code where I'm first putting the scope as GVL. Inside GVL, which variable I need to use, and then I will be again putting GVL, and then I will get the list what all the variables are there, and I will be putting the required tag of variable to which I have to write. Okay, so we will see both read and write here at the same place. Now let me show for the PLC program. So in the PLC program also I have lot of variables defined under, but the scope is local. So when scope is local, you can CoDeSys allow us to read it the values outside of the program, but we cannot write. Similarly, anything defined under var scope, var and nvar, it is marked as a local variable. Means it is not accessible to write outside the program. Okay, but the variables defined in local are allowed to read the value, so we can read it the value from there. Okay, let me call this program 2 in the main program so that it should get instantiated and that gray color mark should get vanished. So let me download. See, always when we are building a major change, then we should be downloading with login as a download. Okay. So if you see the value here, the local variable we are able to read. So the description which we had given, so we are able to read it. Now the global variable which we have, let's change the value. So once we change the value, it is getting written. So we can able to write also the global variable, right? So that is a basic difference between local and global. The scope of local variable is only read only access, whereas for the global we can read, we can read and write. So let me show you the var description in the CoDeSys. So if you see, they defines it in the help that this particular variable, when we define it, has only a read only access. Okay, so we cannot write it externally, and it can be only extended with attribute keywords constant, retain, persistent. So let me show you with an example. So we are trying to access a local variable from the PLC program, and we'll try to write. So let me define one more variable here. So yeah, let's save and compile it. So when we compile, let's see what we get. So it says that UIN is no input of PLC program, means it is not defined as a var input. Okay, so we cannot actually write it. So let me go to PLC program and define one input variable. So these are the different variable type. So in the grid view you can be able to see. Okay, so how we define var input is var underscore input, and then it will do the end var, and in between that scope we have to define the variables. So I'm giving that as a prefix of inp, and then the variable name. Okay, bdi, and let's now try to access. Let me define one local variable where we will be reading. We will be passing this input variable to. Okay, okay, and let's go to program 2 and now do the same thing again. The PLC program dot the variable name inp bi. Let's write to this value. Now compile it. So if you see, the errors are 0, and when we download it, get downloaded, and when we change the variable value, it is able we are able to write it, because the scope was changed to var input. So it will take the input from the external source. Okay, so that is the basic difference. If we have to take anything from the external uh, part, then we need to define it as an input or in out variable, Okay, but the var variable, as scope is local, it cannot be written. We have only read only access. So now let me show you the var in out. So in the var in out, let me define a variable. So what exactly do it will allow us to write it from inside and in the program, and from outside the program where we have the instance, through the instance of this particular. So let me define a variable, and let's define one more variable here. So, and we will try to call out this in not variable in a similar manner as we did for the var input. Okay, let's see whether it works in a similar manner or not. So, yeah, and assign the variable set AI here. And let's save and compile it. You see, we get error because this var in out variable, we cannot call it in a similar manner as input. So it we need to, because this is made to be written from inside and outside both. So let me define and show you how exactly it has to be called. So this is the scope defined for set underscore RAI, and let's go to program, PLC program, and so as we are calling here the program 2. So now if we build, it will be having error. So because the scope has been changed for program 2, we have now init variable. So init variable should be mapped with the variable name and the then the variable which we need to assign with that. So this is the way we need to call it, and when we save and compile it, there will be no error. Okay, so let's download and check this out. So we will now change the value first from the internally from the PLC program where we are calling that. So we are able to change it. Okay, it is getting written. Let's go to program 2 and check. So values are getting updated. Now we can change it from here also, and it will apply to the PLC program variable also. So if you go, so that is why it is in and out. So from the internal also you can change, and from the external to the instance also you can change, and it will get applied to the both. So that is the basic difference when we are defining var input or var in out, and the way the structure has to be created for in out is little different from the input variables. Let's go to the help file, and so here you see the different uh, you will get all the help in this. So how exactly the variables has to be defined. So let's go to var in out. So this is another variable type, is the var output, which will be discussed next. So let's go to first var in out and see what exactly it tells. So it is saying it get passed by reference parameter. So whatever we are passing, it gets referenced there. It has a read write access within PAU, it has read write access remotely. So as we saw, correct. So but a bit cannot variable cannot be passed directly. So that is one thing which we need to be a little careful when we are defining var and out. Okay. So you can refer for any more details the online help of the courses. So let's create a function block. So right now we are doing all the things in the program. So let us create a function block where we will define a different flavors of variable type, and then it will help us to understand more, because when we call a function block, it works differently. So we have to create the instance and then how exactly everything is scoped. So when we create a function block, we get it with input, because something has to be the input parameter for the function block. There should be something which after doing the logic we will get the output, and the local variables. So by default in the structure, this 3 will come whenever we define. So let me define all the variables in different scopes. Okay. So for var in out, we if we define then only in the function block, it will be scoped. Okay. So by default it doesn't come. So we have defined, let me define a small logic so that it will be easy to demonstrate. Okay. So let's define some more variable type here. So you are saying we have all this, and we also have stat, which is var static, and another is var temp. So let me define these two variable type also. So when we change the variable name in the courses, it will show you that where it is getting impacted, and once you say okay, it will change everywhere. So all the mapping will get aligned with this new variable name. So that is a good feature. Okay. So we define both the variables. So let's see how what exactly the static and the temp variable do. So while static is basically uh, defined, and it get initialized uh, every first time each PO is called. And the thing is, for the static, it can be only it means it retains the value. So whenever there's something, it will keep holding the value. So that is the part of the static. And temp value is that it get initialized only for the first time. Okay, whenever the PO is called, it will get initialized. So let's see how exactly it works in the implementation part. So let me change, because we are now playing with all analog value only, so I will define this also as an analog floating real. So now we will put this one variable, the temp, into the one condition and another variable in the another condition, so else condition. So this if else and all about structured text, uh, I will have another video where you can refer for the detail how we implement this. There are different conditional parameters, how conditional scopes, so all those things will come in that videos. So I will have separate videos for ladder, FBD, and the structured text programming, how we do. Okay, so we have done this. Now let's create an instance of the function block, and now call that in the program. So we will go one by one. So we have the four variables. So if you see here, the temp and static, okay, they are not getting exposed outside the implementation. So the implementation is inside the function block, so we will not be able to see those two variables outside. Yes, okay, so they are also kind of local variables which will be residing inside the implementation only, inside the function block. So what we are getting is the input, output, and in out variable. So these three are always getting exposed. So when we are writing the output, so uh, we need to use equal to greater than symbol in order to make it uh, assigned. So it, and rest is with colon and equal to, it works. So let me okay, copy this and we'll put it in the wall, so that we get rid of those errors and the variables get defined. So that is only the intention. Okay, so all the variables are defined. So yeah, okay, now save it and compile this to see if we have any error. So let's download the program and let's see side by side. So in this way you can define the positioning of the flow layout where it has to be positioned. Okay, so they come out and we can position them wherever we want. So let's change some value. So when we change, we will be able to visualize that in the function block also. You see every bits, but temp we are not able to see it here directly, correct? And the static is getting changed when it was in else condition. So right now we have set the boolean width to true, then it was not. Now once we set it to false, the static will start increasing as per the code written. Now, so let me show that whatever we have declared as it shares each time the PO is called. Okay, so it initializes, and the scope is accesses only in the implementation part. So, and the static variable are initialized at the first time of PO is called, and it is also accessible only inside, and then it retains the value, okay, when application leaves the block. So let's check it in the implementation how exactly it behaves. So let's stop the PLC. And let's go. Okay, thing was that I had not downloaded, so it was not updated in the boot project. Let's first download it and make the boot project updated so that it should work on. When we log in again, it will have the same. It should not ask us to download again, basically. To put a breakpoint. So we can also do the debugging. Okay. So you see in the variable of the temp, we are able to see it here when we go in the debug mode that it is initialized with 0. Let me. Okay, so otherwise it was showing the question mark, correct? So now let's make it false. We see that status is keep changing, and now we'll start the PLC and go online. And this time it will not ask because we have not done any changes and everything is intact. So you see it started from the last place itself almost. It is hard to it is hard to understand whether it was from the last date or now, or whether it runs the code run and it is going there. So let me remove this plus one, so whatever value we will write, the same should be there. We'll do the login with download. me set a variable data on the PLC. So okay, so we will initialize all the different variables with some values, and then we stop the PLC. So in case the PLC gets stopped, uh, the values will not get retained, because right now none of these parameters are marked as a retain, and all the value will get lost because PLC was stopped, it is rebooted. Okay, so no value we will be able to see. Again, it has to get initialized from the beginning. Okay, so that retain doesn't mean that it will retain the values even when the PLC starts. So retain is only like it will retain while the programs are running and we are in the runtime. So for the retain purpose, we have the retain variable. So we can mark that as a retain. So what exactly retain do is whenever there is a normal stop process of the PLC, and when it gets started, so it will retain those variable in its memory, and it will initialize back from the same value. So let me download. So I will try to give var input also as a retain. This should be on, and we'll see that. Now we'll change the values. Output we cannot change, so it will be getting generated from the code. So all these values we have changed. Now change the value of status. Now let's stop the PLC and start the PLC, and we'll go online. So you see this status got retained, but other variables doesn't got written. Even we had marked inside the FB them as a retain. Why it is happening? Because these are getting written from the outside, correct? So these are the var input, and those input variables are not retained. Even the so when we start the PLC, what it happens is these variables are getting written from the outside. So the value was not initialized with anything. So that's why those parameters doesn't get retained. Only the status, because that is local and it is a scope inside the function block only. So let's mark the variable as a, which we are passing to which we are writing into the FB. let's mark them as written, and we will descope the variable inside the FB and remove it from the written part. Okay, and now let's check this. Let's change the values. So all the values we have changed, and now let's start in the PLC and go online. So you see, set B on was marked as a retain, so that got retained, other variables not. Okay, and inside the FB, status was marked as retained, so it also retained. So when we just stop the PLC, these values get retained. Okay, so that is the functionality of the retain variable, that it will retain all the values till the PLC, we start and stop the PLC, and doesn't do the power recycle. So let's output anyhow will be getting generated from the code. So okay, so let me mark another type of variable parameter is persistent. So persistent is something which will even retain the values when we power the cycle the PLCs. So it will be hard to show it here, but as we are running on the soft PLC, the PC based PLC, but uh, it will work, and I will just guide you how this persistence variables are defined. So only just marking them as a persistent, uh, it will not make it work. So let's see, I have marked them as a persistent and change all the parameters value. So all the values are changed. Now let's stop the PLC and start it again. Go online and see. Okay, so the variables which were marked as retain, those values get written, but the variable which were marked as persistent, it did not. So it happens because we have not defined. So there is a object which we need to add for the persistent, that is persistent variables. Okay, when you add it, we have to also call the variables which are persistent. So easy is that all the instance, add all the instance path. Okay, I need to first compile it, because after adding the persistence bar, I have not compiled. So after that, add it. So all the variables which were marked as persistent will come here in this list. And now let's see whether they retain the value or not. Just change all the values, apply it, and then reboot the PLC. Sorry, not reboot. Stop the PLC and started the PLC. So now if you see, all those variables are retained, correct, after starting and stopping the PLC, stopping and starting the PLC. So yeah, so persistent, this is what it exactly do. So it has defined here all the all the things which we did, and some tips which courses provided, that what we should not be doing when we are defining a persistent. Okay, so as I was telling, so the persistent data type retains the value when the application is reloaded. Okay, and retain variables are retained only when we have the warm start, but not when we reboot or reload the whole program. So that is the basic difference between retain and the persistent. Okay, so that's all from the variable types. Let's see you in another video where we will talk about uh, programming in the different languages supported by IAC. Thank you.